Hey guys, it's Mrs. Lindsay here. Mr. Falco, Miss Persico, and I send you our regards. We have missed you so much. I've been working on some slides for you to play with. You've done a great job so far with your Desmos. So here I am at my house/TV studio to show you how we can change a standard quadratic equation to the vertex form you've grown to love so much. So I think it's best we use complete the square since we already know how that works. So let's get an example here. Can I work with this standard form of a quadratic? The answer is yes, I could by using the axis of symmetry formula, x equals negative b over 2a, but then I would still have to find the y coordinate by substitution. So let's try to use complete the square and change this to vertex form. First order of business, I need to remove the constant because it's not the perfect square that we need. It certainly doesn't work well with the middle term. As you recall, you need a perfect square for your perfect square trinomial, and you need one that works with the middle term. So if I subtract 8 from both sides, the subtraction property of equality, I'll have f of x minus 8 equals x squared minus 16x. And now I'll be free to add whatever perfect square I like. I'll just add blank to both sides. Hopefully this is all coming back to you. So you'll have f of x minus 8 equals x squared minus 16x, and you can add your perfect square as long as you add it to both sides. Here's a clean slide for you. So the perfect square that I would like to add to both sides is one that works well with negative 16, the middle term. And if you remember what we did to get the perfect square that works well with negative 16 is we took half the middle term, and squared it. So we'll try taking half of negative 16, which is negative 8. When we square negative 8, we get 64. So 64 is the perfect square that we'd like to add to both sides of the equal sign. Again, the addition property of equality comes in handy with algebra. We can add the 64 to the negative 8 we already have on the left side, and that'll give us f of x plus 56 equals the perfect square trinomial we just invented, x squared minus 16x plus 64. Here it is all typed out for you. The next order of business is we need to get a perfect square binomial out of that perfect square trinomial. So we still have f of x plus 56, but if we can get that trinomial into a perfect square binomial, and I think we can because we have a perfect square, x squared, that becomes x. We have a perfect square in the constant, 64, that becomes 8. And as long as it's half of negative 16, and we'll get that by adding a negative sign, and there's our perfect square. All we have to do is solve for f of x. And it's a simple matter of just subtracting 56 from both sides. And there we have f of x equals x minus 8 squared. That's the perfect square binomial. And the y coordinate of the vertex, negative 56. So now I think you can probably find the vertex from that. You could have tried Desmos, you could have tried your graphing calculator, or you could have tried the axis of symmetry formula, But I think in most cases it would have been difficult to get the y coordinate. It's so far below the x-axis at negative 56. I think this would have been the ideal way to go about it. So hopefully you'll see that the inside is the opposite of the x-coordinate of the vertex. So the vertex would be positive 8, and the y-coordinate is the outside, same sign, negative 56. So there's your vertex. Can we check with Desmos? Apparently not. And there it is. Okay, so 8, comma, negative 56, the vertex of the parabola. Let's try this one more time to see if we got it. Step 1. We want to eliminate the constant. Subtract 1 from both sides. We now have g of x minus 1 equals x squared minus 6x. We're going to add our own blank as long as we add it to both sides. Where do we get the blank? We need to look at the middle term, which is negative 6, take half and squared, which is negative 3 squared, which is positive 9. Positive 9 gets added to both blanks. On the left side, 9 gets added to the negative 1. I have g of x plus 8. And on the right side, we have a perfect square trinomial, which we're going to crunch into a perfect square binomial, taking the square root of the x squared and the square root of the constant and making sure the sign of the middle term matches. And now it's an easy case of just subtracting 8 from both sides to solve for g of x. We have g of x equals x minus 3 squared minus 8. Hopefully you can find the vertex now. Inside is the opposite of the x-coordinate. That would be positive 3. Outside the parentheses is the same sign of the y-coordinate, making it negative 8. Let's just check with Desmos to make sure that we're correct. Hopefully it comes up. And there it is. Positive 3, negative 8. We could graph this. If we use positive 3, negative 8, 1, 2, 3, 4, 5, 6, 7, 8. We use the table on our graphing calculator. And here's a very rough sketch of g of x. Okay, it's your turn. You have your slides, you're ready to go. You can play this video back if you need. And good luck. I'll see you tomorrow with parabolas that are concave down. A equals negative 1. Talk tomorrow. Have a great day. Stay good. Stay out of trouble. See you then. Bye.